Your first wet lab will be next week, and that requires a formal write-up. Everyone does know I postponed the test till Tuesday, right? You're not expected to take the test today, right? Because there's no test to take. All right. You're going to need a lab notebook. That's a I don't see anyone with one. It's a it has to be bound. In other words, you can't shake the pages out. It has to be sewn like a comp notebook. And you can even buy them for a couple bucks. What did this cost? Yeah, it's very inexpensive. First thing to do is number the pages, leave one page for table of contents in the beginning. We're going to begin each new lab on a brand new page on the right side. You're only writing on the right side because notebooks nowadays have very, very thin paper. And what happens is that the pen you're using frequently will bleed through. I can show you some examples of bleed through. So really writing on one side of the paper, it's always on the right side. You need to number your pages. You can number both the left and the right page or the right side only, doesn't matter, because the table of contents is going to point to the right side page anyway. Okay, you can only use indelible ink. Indelible means it's not erasable, permanent. Some inks you can erase and no pencil, no whiteout. I know in 305 you didn't have a formal notebook, but in all classes except for 305, there's a formal write-up required. Okay, so no whiteout. Okay, so when you make an error, you're going to put a single line through it so I can read the error. In other words, everything has to be legible and readable in your notebook. That's why there's no whiteout. There's no erasable pencil or erasable ink. Everything is permanent. Now, taking any lab class is going to be similar to this unless they allow electronic devices. Now, if you want to use your tablet, that's fine, but you have to write on it. Last semester, about a quarter of the class used their tablets, and they just wrote on it like it was a piece of paper. Okay. Now, at the end of the semester, it's kind of weird when you have electronic one because you have to turn it in for a final grade. And what I'm looking for is a table of contents there? Are the pages numbered? Are the table of contents up to date with all the labs in there? I'll give you another lab grade. Usually it's quite good. Most people do fine on that. If I shake your notebook, does anything fall out of it? That kind of stuff. Okay, so that's at the very end. Now, this pre-lab is due at the beginning of the period. In other words, this is your ticket so you can do the lab. Now, your first lab is next week. It's on steam distillation of citrus rind. And it's a pretty cool lab. I'm using some pretty sophisticated glassware setups. So everyone needs to bring an orange or a lemon. Doesn't matter which one. You can use a tangerine. What we're going to be doing is we're going to be taking the zest off the rind, not the white part, just the colored part, either yellow or orange, depending on what fruit you bring. Then we're going to do a steam distillation, which pulls out what makes a citrus smell citrusy. So the parts that you're going to be needing Well, obviously you're gonna have a table of contents in the very first page. You're gonna have a materials list. Let me go up here. So all labs, you're gonna have a title. You're gonna have a purpose. Why are we doing this lab? And you're also gonna have, for each chemical you use, except for water, you're gonna have a first aid. Now you can get that in a number of different places. The easiest way is just to go online and do a search. And I can show you how to do that in a minute here. And I don't believe in busy work. A lot of people feel the first aid part is busy work. It's not. I want you to be exposed to all the chemicals and the first aid associated with it. Okay. Now, if we reuse the chemical, like frequently we'll reuse hydrochloric acid, you don't have to redo the first aid for it. You just say C lab, whatever. Now you can redo it if you want, but if you don't want to, just say C lab, whatever. Also, if the chemicals have the same first aid, you don't have to keep repeating it. So in other words, if you had like potassium nitrate, sodium nitrite, those are going to have the same first aid. So there's no point in repeating the first aid. Just put commas with the chemicals above. Also, on the first wet lab, you can fix everything. So in other words, if you got a 12 out of 15 because you forgot to write your conclusion, something like that, you can fix it because you've never done one of these before. And so I'm going to allow you to fix it, okay? After that, you get what you get. But the first lab, everyone should get a perfect score, assuming you want a perfect score. Remember, labs tend to be, they take a while to do, but they're not hard. It's a matter of putting in the time. And they do take some time because you're going to have to write out the procedure. Notice on this one how, I don't know if you can see it or not. See how the bleeding has come through? You write on both sides of the paper. That's why I write it only on one side. Most professors require you to do blue or black ink. You can do it in any color you want in my class. Some people do drawings and stuff for the setup. And some people are quite good at it. Quite good. They'll do three-dimensional drawings with shading and all that stuff. It's really kind of cool. But you can use multicolor ink if you want. That's fine. All right, let's see here. If you have a data table, that's going to be part of your pre-lab setup. And you can change it once you start the lab, like adding stuff or whatever, but you need to start with at least one data table. And the purpose of a data table is to organize a place where you can put your, what did it say? It just told me something I don't know. It's a place to organize where you want to write down your data. And it could be an observation, or it could be a mass, it could be a temperature, could be a volume. All those are typical data for your data table. Okay, any number less than 1, put a 0 in front, like these guys here. Okay, the purpose of that is not so much with a tablet, but if you're on paper. We use a lot of water around labs. When the lab water splashes onto a page, it leaves a dot. So if you put a 0 in front with a dot, you know it's less than 1. Now, oh, battery low, that's what it's saying. In the medical field, this has happened numerous times, and people have died from this. because this decimal point was misplaced, including children, like Swedish Medical up in Seattle had 2 deaths because of this. One was a child and one was an adult. Some deaths happened in Texas as well at medical centers. So it's really important to get in, especially all of you and theoretically allied health. You should get used to doing this 0 point, okay? Now, if you would have had me for 305, I would have insisted upon it, but just get in the habit of it. Okay. Materials list. Let's see. Now, all labs require a conclusion. And I'm not requiring 2 pages for a conclusion. I'm talking about a solid paragraph. And all you're doing is you're just saying, what did you learn in this lab? For example, the steam distillation lab, you can go back to your purpose. Why are you doing the lab? Why are we doing the lab? And every lab is going to have a background. And usually from reading the background, you can figure out why we're doing the lab. And then you go to your conclusion and just say, what happened? You know, did your orange peels fall on the floor? Someone stepped on them, you couldn't use, you know, whatever. Okay, all that goes in the conclusion. Procedure for the pre-lab. And as you do the lab, you have data, post-lab questions, and then you have a conclusion. And it's always due a week later, just like with your tri-lab. Week later. Okay. So, are there any questions about this guy? I wanted to show you how to do a SDS lookup here in a minute here. So say we had hydrochloric acid. So you can go SDS, hydrochloric acid. And every SDS document is a PDF file. And they're all set up the same way. They're in sections. The section that you need to be concerned about is section 4, which is first aid. Now, if you are pregnant, thinking about becoming pregnant or breastfeeding, you need to also go to section 11. So here's first aid. Talks about skin contact, inhalation, eye contact, etc. That's what you're going to need to put down in your write-up. And then on section 11 is the toxicological information. In other words, is this a carcinogen? Is this a teratogen? Which is important if you're in that mode. Okay. Also, this applies to men as well that are also trying to become build a family. Okay? So it affects eggs, it affects sperm, etc. Now, who knows what a teratogen is? Anyone who's heard of that before? Yep, very definitely affects the fetus. How does it affect? Yeah. Abnormalities. Thalidomide was an anti-nausea drug given to women in the first trimester. And it caused horrendous birth defects. The children were born with no arms or legs. And it had to do with a D and an L form of the thalidomide. One of the forms reduced nausea, the other one caused the birth defects. So that teratogenicity is a big deal. Okay, so anyway, if you're in that situation, you're trying to have a family, et cetera, definitely look at section 11 on the toxicological effects. Okay, and any when you do this and the file you're clicking on is not a PDF, it's not an SDS document. So just find one that's a PDF. And all manufacturers of chemicals, legitimate manufacturers of chemicals, publish these. In the United States, it's the law to have to. Some get shut down for that. It's a big deal. And the nice thing about it, internationally, we standardize it. So section 4 is always first aid, regardless of who's making the SDS document. Also, we have them in the lab. If you want to just do it in the lab, you can also, they're all printed out for you. So for me, it's easier just to look it up rather than paw through this document this thick with all the SDSs in there. Okay, so this makes sense. All right, cool.
Security. Thank you.
Now, if you go to modules and lab related, you'll see a video as well, which is basically kind of repeating what I just went over. Okay, so does anyone not have their lab packet? For the student, that last semester they were out for like 4 weeks. It was such a freaking pain. Okay, so everyone's got a copy. I don't need to get about the digital ones. Okay, is everyone doing okay regarding the dry labs? How to submit them and all that stuff. Cool. All right, I'll start grading those sooner than later. Okay, I'm not 100% from Tuesday. Tuesday, I was in bad shape. So I'm going to start unit 2 on aldehydes and ketones today. I'm going to go up to reactants. Talk about nomenclature, what is an aldehyde, what's a ketone, that kind of stuff. And then I'm going to end it there. You know, I didn't stand up in front of you guys. You have to do my conditions. It's very terrible. What I suffered on Tuesday. Yeah, see, it's something I did. I don't think, wow, I shouldn't say that. It could have been. Also, when you get old, things like that. All right. So let's now get into okay. Now, unit two is going to involve carbohydrates as a biochem unit, especially with aldehydes and ketones. I think the aldehydes and ketones is the chemistry of carbohydrates. That's why we're going to cover this, and then right away we're going to talk about carbohydrates. Aldehydes and ketones, and to some extent acids as well, centers around the carbonyl group. The carbonyl group is a double bonded carbon oxygen. So we've had an alcohol, which is a single carbon oxygen bond with a hydrogen attached, and also an ether carbon oxygen. Now this is a double bonded carbon oxygen. Okay, an aldehyde, the carbonyl group is on the end, the ketone is in the middle. And their chemistry varies a fair amount. Aldehydes are much more reactive than ketones. Ketones are much more stable than aldehydes. Aldehydes tend to have a problem where they react a lot. In fact, when your body is detoxifying ethanol in your liver, one of the intermediate steps is it oxidizes the ethanol to the aldehyde. And if you don't have the right enzyme in your liver to detoxify that aldehyde, that's what causes cirrhosis of the liver. The aldehydes want to react, not receive. Okay. So the simplest aldehyde is formaldehyde. And it's just got one carbon, one oxygen, and a couple hydrogens. Now the problem with formaldehyde, you use it frequently to preserve tissue. They call it formalin, embalming fluid. There's all these names for it, but it's all formaldehyde. Formaldehyde is not good for you, period. Also, they use it in industrial glues as well. For example, if you live in a brand new home or brand new apartment complex, there's a good chance you're being exposed to formaldehyde. Because what happens is formaldehyde is very volatile. So when that glue heats up in our nice warm summers, it vaporizes into the air. And of course, you've got all your windows shut, you've got your air conditioner on. So guess what? It just stays in your apartment or your house. So remember that when you're taking A and P, you can be doing a lot of formalin related stuff. Just be careful on breathing it, especially if you're trying to become pregnant or breastfeeding, particularly. It's really bad stuff. Okay, another common ketone, simplest ketone is acetone, and that's also not very good for you. And it's much more stable in formaldehyde, but it's still not particularly safe. It's used a lot in things like fingernail polish remover, lacquer thinner. It's used in the fiberglass industry as a solvent for the epoxy. It's used a lot. So that's the simplest ketone. And the simplest aldehyde is formaldehyde. Okay. So naming aldehydes. Aldehydes are going to have the functional group name is Al. Think of aldehydes. And it's the same thing. We have 3 parts. Look at the back. See, this bugs me. See where the pointer is? I keep calibrating this tablet with this new computer, and it's always off. I'm almost ready to bring my old computer back. Okay. So again, they all have 3 parts. So let's look if we have a okay, we've got a 1, 2, 3, 4 carbon. So that's bless you, butanal. And there are no branches. Well, let's throw a branch in. Let's throw a methyl group here. So now the functional group always determines the numbering on the backbone. So with aldehyde, that carbonyl in the end is always carbon number 1. So that's 1, 2, 3. So that would be 3 methyl. Why does it work? See, it's working fine now. Then I go over here. Okay, so it's the standard 3 parts. You've got Al at the end to by, and the aldehyde is always on carbon 1. It's always on the end. Sometimes you can have 2 carbonyl groups within the same molecule, but a standard aldehyde, it's always carbon number 1 on the end. Ketones cannot be carbon number 1. By definition, they're in the middle. Okay, so if you've got a 5 carbon backbone, an aldehyde can only be in carbon 1, or it can be in carbon 5 also, but it's got to be on the end. And if it was a ketone, it has to be on 2, 3, or 4. Can't be on number 1 or number 5. Okay? Other than that, they're pretty simple to name. So remember now, the backbone has to, no exceptions. All right, these are some common aldehydes. Already mentioned formaldehyde. Acid aldehyde, that's based on acetic acid, where it gets the acetaldehyde there, or ethanol. This one isn't all that common. Benzaldehyde biochemically is pretty common, and that's based upon the aromatic benzene ring. Now, ketones are going to be the same thing. You're going to have a backbone that contains the ketone. You're going to have an ONE, like acetone or ketone, ONE at the end. And then you're going to have the branching. It's very, very consistent with the IUPAC naming. And again, I'm going to reinforce this. Ketones cannot never be carbon number one. Now, what do you think about that? Except for cycling. Okay, common ketones. Acetone is probably the most common one. MEK is another common solvent. Methyl ethyl ketone. It's used in the paint industry a lot. It's used in the glue industry alongside of formaldehyde. It's used, you might even find it in nail polish remover. A lot of places you'll find MEK. Okay, now, unit one, I talked about intermolecular forces. If you have oxygen present, usually that molecule is polar. Now, it's particularly polar with alcohols because it's hydrogen bonded. Now, we're going to find with carbonyl group with aldehydes and ketones, it's definitely polar, but not as polar as hydrogen bonding. This would be just called a dipole-dipole intermolecular force or a permanent dipole. And this distinction of that little squiggly thing is called partial. It's used a lot in the math field. For example, if you're doing partial differential equation, you use that a lot. It basically means not full on, a little bit. So the oxygen is a little bit negative because it's more has more electronegativity than the carbon. The carbon is a little partially positive. So you'll see this a lot in OChem and biochemistry. It's a partial sign. And if you take lots of math, you'll see it in math used a lot too. Now these four compounds have similar molar masses, but the boiling points differ remarkably. Okay, so here we have alcohol, highest boiling point, highest melting point, highest surface tension. The alkane, the lowest. Ketones and aldehydes are in between. So if you're going to rank them, you see 5, 6 chemicals on there, and they ask you to rank these in boiling points or melting points or surface tension. You would find the ones that have a hydrogen bonding first, which would be the alcohol, and acids we'll find in unit 3. And then the aldehydes, ketones in the middle, and ethers, and then lastly, the bottom, alkanes. I'm going to see a graph of that in a minute. So ethers are going to be a little more polar than the alkanes and alkenes. But not as polar as aldehydes, ketones, not as polar as alcohols. Now, usually ketones and aldehydes are soluble in water. As you know, water is very, very polar. And because of this partial negative and partial positive, that makes that carbonyl polar as well. So that's why they're soluble in water. Unless you get long carbons on the end, like 7 carbons or more, then they're not soluble anymore because the London dispersion forces overcome the dipole part of the oxygen. Now, let's see. Now I'm going to have a different flow chart for you for Unit 2. What it's going to do, it's going to extend the Unit 1 flow chart, adding in aldehydes and ketones. Not going to extend it a lot, though. Most of the chemistry of aldehydes and ketones, except for one exception, is in the Unit 1. In other words, they can be oxidized and reduced. So a primary alcohol goes to an aldehyde. A ketone is a secondary alcohol is oxidized to a ketone. And the aldehyde can undergo further oxidation because it's got a hydrogen here. Remember, oxidation is losing hydrogens, reduction is gaining hydrogens. So that carbonyl group on the aldehyde has got a hydrogen it can lose under oxidative conditions. And then goes to the acid. And the ketone doesn't have one of those, so it can't go any further in oxidative conditions. It stops at the ketone. Now, back in the old days, back in the 40s and 50s, CSI labs would do a lot of wet chemistry diagnostic. They would add stuff together and saw, is there a color change? Was there heat given off? Was there gas given off? Something like that to determine stuff like this. Nowadays, none of that is done anymore. It's all instrumental. Now we're going to be using an infrared spectrophotometer when we do our aspirin lab. So you're going to actually see that. Basically, it's going to create a spectrum of how all these individual atoms interact with one another. And it's very diagnostic. So you don't need to do wet chemistry to determine the difference between an aldehyde and a ketone. It's all done instrumentally. Okay, so if we take acetone, ketone, benzaldehyde, and aldehyde, and oxidize each one of them, the one okay, so the ketone is in the middle. The aldehyde is on the right. And this is an oxidizing agent. It happens to be dichromate, acid dichromate. Okay, so when oxidation reaction occurs, the oxidizer is going to change color. So this is the oxidizer, so it's yellow. So throw it in each one of those test tubes, we put it in the one with a ketone in it, no change. That means the ketone was not oxidized. That's when we know it's a ketone in there because the color didn't change. When we throw the oxidizing agent in an aldehyde, big color change. So oxidation occurred. So that's why we know that one is an aldehyde. Okay. This is the first of a series of reactions you're going to need to know for Unit 2. Holland's reagent is used to test whether there's an aldehyde present or not. What happens is the Holland's reagent, which is a silver cation, is reduced. Okay, so it goes from Ag plus 1 to Ag 0, silver metal. And what happens to the aldehyde? It gets oxidized. And it gets oxidized depending on the pH. In this case, the pH is very alkaline or very high. It goes to the acid salt, which is this guy here, carboxylate salt. Now we're going to see when we get into carbohydrates that carbohydrates can open and close. You always see them as ring structures. That's because that's the most stable configuration. But they do open and close as well. When they open up, they expose themselves to be an aldehyde. And that aldehyde then is susceptible to oxidation. So that's one test. It's called a reducing sugar. We're going to study that in detail. Okay, so the Holland's reagent, it's a really cool reaction because the inside of the test tube forms a silver mirror, real shiny. That's why they used old mirrors are made from silver. The plate, silver plating in the back of glass. Again, so the glass is nice and shiny. The silver plating on it becomes reflective. And antique mirror repair uses this reaction to fix dings on the ends of mirrors. What they do is they replate the silver on the back side of the mirror using this specific reaction. Antique mirrors are very fragile. Okay, anyway, you need to know that guy. And there's another very similar reaction. It's called Benedict's reaction. Benedict's reaction does the same thing. It oxidizes the aldehyde. So what happens is the aldehyde goes to the carboxylate ion or salt. And then the copper plus 2 goes from +2 to +1. That means it's being reduced. Benedict's solution is a better test for an aldehyde versus ketone because it reacts really fast. Holland's reagent, it's kind of a cool reaction because it's silver, but it takes a while. And sometimes it doesn't produce pretty silver because silver can tarnish, but sometimes it makes tarnished silver. But this Benedict's solution reaction reacts within seconds. Okay, so we've got glucose solutions here. And we throw in the Benedict solution, which is a nice, pretty copper into both of these. One has got a dilute glucose, the other's got a more concentrated glucose. So the reaction is going to change color, but the one with the most in it is going to have a deeper color. But it's going to go from a blue to either that orangey or this kind of greenish blue color. But this is another reaction you're going to need used a lot with carbohydrates. So this is aldehydes can be oxidized. They can also be reduced. When they're reduced, it goes back to their primary alcohol. And then ketones under reductive atmosphere go back to the secondary. So we have a three carbon aldehyde. It's reduced to a 3-carbon alcohol. So this has got okay. And this would be in a reductive atmosphere. Okay, I'm not going to talk about this today. These reactions talk about what if you have an aldehyde and an alcohol together, what do you form? You have a ketone and an alcohol together, what do you form? And you form acetals and hemiacetals and hemiketals and ketals. So we're going to stop today there. And this is the essence of carbohydrate chemistry in this series of reactions. Because this is how glucose would link up with this reaction. Okay, so I'm going to end it here. I'm going to start lab a little early as well. Some of you already got the packet. So bring those with you. So are there any questions so far? Yeah.
And there's an aldehyde. Is it because there's an H attached to it?
With the carbonyl.
And
So it's an H and a carbonyl.
so the carbon, H attached to a carbon.
The carbon is not the bond.
Oh,
It's an H and a carbonyl.
that's what's.
And it's carbon that's separated. Remember, everyone, there's tutoring assistance for you in the library under educational research. Chemistry tutor there specifically for 3 on the a number of you have been doing that. Just keep that in mind. If you that rules down, right? Yeah.
Overlap, but he didn't know how to do the reactions, so I'm still a little bit on that.
He's Stephanie Cortez.
No, all the snaps that I saw, Sarah.
Stephanie Cortez was saying about, chemistry therapy.
Yeah, well,
If you want to show the return.
how do I do it? Because when I was set up on the app.
I would call the regular company. I would give them a call. I would give them a number.
Yeah.
She's there right now. Let's go talk to her. If she's in there. Yeah, she's at the desk. Sometimes she works. I figured out what teacher she's to.
He's in charge of this.
Oh.
He's in charge, sure. Yeah.
Are you good on the actions?
I've been studying, reactions with alcohol reactions. So I'm pretty good at
And I
that.
have your number.
Does she have a draw that too? We weren't doing that. We're still not doing it on the test, right?
Correct.
I
Yeah.
just wanna make sure.
Definitely not, because we don't have it in our body. So there's allied health. That means you're doing stuff related to health. And if it's not in the body, same with plastics. We're not doing plastics. We're gonna do polymers though, but it'll be biological polymers. Sure.
I didn't get the lab.
Oh, you're not, you want to send me something.
From this bookstore?
Okay, yeah.
It should be.